Alrighty then, corn children. Children of the corn. It is integration by parts, part 2. Now, before we get going, we are going to do a not integration by parts, but a hey, let's remember how to do this integration problem. This is just plain old U substitution. All right, so if we need to integrate the sine of 3x with respect to x, we need to let u equal the 3x, and when we take the derivative of this, there's this 3 here, but there is no 3 in the problem. So we need to fix this by dividing both sides by 3. So now, when we substitute out the variable x, this becomes sine of u. The dx is replaced with 1/3 du. And now we know how to integrate sine of u with respect to u. It is, of course, there's your scalar, negative cosine of u, and I'm going to put the 3x back, plus c. Now, we're going to need to remember this much more efficiently, much faster when we do integration by parts. But listen, by the time we get to integration by parts, we should be good at this, all right? So try to remember that, or rewind the video. Because here's the actual problem we need to do for today for integration by parts. All right, we're going to integrate x sine 3x. Oh, it's almost as though these are related but not the same. Yes, there is an x here. Corn children, look at this. This is a product. This is not a basic integration. It's a product. We are going to use integration by parts. So, integration by parts. We need to split this problem into two things, a u and a dv. From our first video, dv needs to be the most complicated factor we can integrate. Well, we know how to integrate sine of 3x dx. We do? Yeah, rewind the video. We did it like 5 seconds ago, okay? X is going to be the u, and if possible, it's a secondary choice. This is your primary driving factor, but as a secondary choice, when we take the derivative of x, it becomes simpler, so that it also guides us. All right, so how do we do this again? All right, we will take the derivative of u, and we will do the antiderivative, also known as integration, of dv. Now, when I do these, I'm picturing all of this in my head. I'm not actually writing this out in every single problem. If you need to, you can do that on the side of your paper, but I'm kind of hopeful that you can remember when you integrate sine, it's negative cosine, but because of the u du on the 3x, there's a scalar of 1/3. Yeah? All right, if not, do that on the side of your paper. Now, what do we do with all of this? Well, we have to remember that this was our u, this was our dv, and when we integrate with parts, it becomes uv minus the integral of v du. So I'm going to substitute everything in. Here's u, here's v. I'm going to multiply these together, and because I don't want to use parentheses, I'm going to rearrange it. So it's negative 1/3 x cosine 3x. So there's v with the u in there, minus the integral of v. Now, let's think ahead. I'm going to pull the scalar and the negative, v du is dx. Yeah? Okay. Yes, these cancel. And now we have to just integrate cosine 3x. Well, it's technically not this same variable, but we do a teeny tiny little u du in here again. Don't forget, we got to do these things. And again, there's another scalar of 1/3. Now, integrating cosine, you get positive sine 3x, but we will have a scalar. So here we go. We bring this term down, negative 1/3 x cosine 3x plus, here's the first 1/3, And then when we integrate cosine, we get positive 1/3 again, sine 3x plus c. So we have a 1/3 from the VDU, or the DVV, and we have a second 1/3 on the little baby integration here. So this, of course, just take that out and make it a 1/9 sine 3x plus c. Booyah.